This is part 4 of a 4-part video series about the molecular biology of COVID-19 in 2022.
Now that you've learned COVID-19 symptoms, treatment, and vaccination, let's get you updated on a recently discovered phenomenon, the long COVID syndrome, post-recovery, that infuriates people's health in various ways. As of this portion's focus of research, it is discovered that recovered patients from COVID-19 experience syndrome aggravating the human body's cognitive system, mental health, and physical health. One may experience exacerbated heart failure, chest heaviness, breathlessness, fatigue, muscle pains, palpitations, cough, and joint pain. In some cases, some patients develop heart muscle inflammations, lung function abnormalities, kidney issues, rashes, hair loss, smell and taste problems, and also sleep issues. Mentally, symptoms are worsening in anxiety and depression. Cognitively, some survivors have problems with concentration and memory, as known as the brain fog. Furthermore, people report that they still experience symptoms of COVID-19 even after a month when they're no longer tested positive. A systematic review highlights around 55 long-term symptoms of long COVID, including but not limited to these numbers. 1 in 10 people experience symptoms and impaired life quality after COVID. For this widely recognized phenomenon around the world, in Europe, UKRI and NIHR founded 18.5 million euros for research on its sequelae. Next up, the immune system response is defined as the reaction of the body against the presence of a foreign substance, an antigen. As a defense line against infections, a system of cells and organs work together. Our main characters are the leukocytes, as we may know, the white blood cells. White blood cell phagocytes tear apart invading organisms. One type of phagocyte, the neutrophil, fights against bacteria. Therefore, in this way, doctors can diagnose whether a bacterial infection is in place with a blood test. A significant rise in neutrophils indicate the presence of bacterial infection. And then there's cousin lymphocytes who help destroy invading organisms, study and memorize them. B lymphocytes matures in bone marrow, lock into invading organisms and send defense instructions. They make antibodies lock onto specific antigens. Note, antibodies stay in the body to prevent the same intruders to invade the body again, as we mentioned earlier in this video. This example also explains how one won't get sick from chickenpox again. T lymphocytes matures in the thymus gland, follow orders of B lymphocytes, and destroy the spotted invaders. This video also wants to introduce you to 3 types of immunity provided by these dedicated warriors. First up, we have the innate immunity. It's a protection everyone is born with. For example, the skin acts as a barrier to block outside bacteria. Next up, passive immunity, which is borrowed from another source and it only lasts momentarily. For instance, antibodies in breast milk allow the baby to be temporarily immune to diseases the mother has been exposed to. Lastly but not the least, adaptive immunity develops throughout human lives, developed when exposed to disease, and developed when one is immunized with vaccines. In our case, the case of COVID-19 vaccines. Just like how people can be flawless, our immune system makes no exceptions. There are primary immune deficiency that occurs in people born with a rather weak immune system, followed by acquired immune deficiency as the immune system weakens by catching certain diseases. An allergic reaction is an overreaction of immune system, aka autoimmune disease, where the immune system harms the body itself. Survey shows a small proportion of the after COVID population that experience an overreaction of their immune system, which has led to heart inflammation, damage to organs, and etc. The University of Cambridge and Addenbrooke's Hospital, Cambridge University Hospital's NHS Foundation conducted research for those tested and cured from SARS-CoV-2 to the COVID-19 cohort of the NIHR bioresource. also medically given rise to one of the key findings yet to be peer-reviewed. Persistent abnormalities in immune cells and a change in the body's inflammatory response may contribute to long COVID.